So today, we're here to talk about reducing business risk. Yesterday, we talked quite a bit about Zscaler for workloads, and today we're going to talk about Zscaler for users. But before I get started, again, we shall be making forward-looking statements, so safe harbor applies. So let's get right in. I'm sure many of you are still wondering, despite all the investments in cybersecurity, why do we still see so many breaches? And I think it starts with the fundamentally flawed architecture of a network-based, a perimeter-based security model that's out there. And if you look at this diagram, and you've seen probably versions of this, the whole network-centric model has the data center at its center, and then as your branch offices emerged, you connected them over a flat, routable network. As your users moved outside through COVID, they started connecting back to the network using VPNs. As you've expanded from your data center to public cloud environments, you have that flat network now extending. And in order to protect all of that, the traditional mindset is to have lots and lots of virtual firewalls deployed everywhere. And if you take a look at this from an attacker's perspective, this is just a massive, juicy attack surface to now exploit. What used to be very concentrated in a few locations is now spread out. And that's what they really do. They have a rich attack surface to exploit. They find a few vulnerable points of entry. It could be a user. It could be a firewall VPN concentrator with vulnerabilities. It could be a server exposed with Log4j. All you need is one. You enter. And once you've breached that perimeter, whether it's a user or a machine, that becomes the beachhead for further lateral propagation. And this lateral propagation problem is something that's not very well understood. And we see this cycle over and over again in organizations where an initially compromised user or a compromised machine becomes a beachhead, and that threat moves laterally towards the crown jewels of the organization. And finally, that leads to the objectives from the threat actor, which is either data exfiltration or extortion or ransomware. So we see this cycle repeat over and over again. And when we look at cyber risk, the question we ask is, what are the things that we can do to disrupt this simplified kill chain at each of those 4 stages? So let's take a look. The foundational principles of Zscaler's Zero Trust architecture was to attack all of those 4 vectors that we talked about. So how do we do that? Today, any user, any device that comes to Zscaler is, we terminate that connection, and we first assert identity. We figure out who the user is, right? We won't let you go without knowing your identity. So it's a terminated connection. That's the difference between a firewall's pass-through architecture versus a proxy that is stopping that connection. Once we stop that connection, we then verify your identity. We look at who you are. We look at the context. We look at where you're heading to. And then, most importantly, we start analyzing the content of your transaction. And in order to do that, you have to do full SSL inspection. You heard from Alex yesterday that 95% of all his traffic is encrypted. If you're not inspecting that content, you're going to be blind to almost everything that's going in and out of your organization. So we verify identity. We look at the content of your transactions. We evaluate risk dynamically. We inspect the pages of those transactions, both what you're sending out, what is coming in. And based on that continuous risk assessment, we are able to stop data exfiltration, preventing stuff from going out, and stop malware from coming in. And then further, we then enforce dynamic policies. And policies could be, allow that transaction, block it, caution, put it in a sandbox, and there are some other techniques such as deception that we've now introduced as part of the policy action. And finally, after all of that is done, we allow that user to go to the destination. And this is true whether you're going to an internet-facing destination, a SaaS application, or a private application. And if you look at this model where we are doing this 240 billion times a day for every transaction going through the platform, we're not letting anything just go through. And so The 4 areas of risk that we talked about, from eliminating the attack surface to preventing lateral movement to stopping data exfiltration, all of that happens with this model. The other thing that most people don't realize is when you start using a service like Zscaler, nothing is exposed to the internet. You're all behind Zscaler IPs. So what threat actors see is just Zscaler, right? And you can't attack what you can't see. Now, if you compare and contrast this with a traditional firewall, VPN-centric model, you can see that it just falls short in every dimension, right? Firewalls are actually expanding your attack surface, more points to exploit. They're really not preventing lateral movement because the internal networks are flat. And you can see some of the other challenges as well. Now, to give you a holistic view of risk within your organization across all of those 4 areas, we are now shortly going to start previewing this risk report that looks at your logs and gives you an overall view of risk in all of these 4 areas. Your external attack surface, your risk of compromise, your risk of lateral propagation, and data loss. And what is more interesting is we want to give you key recommendations based on our analysis. And those recommendations could be as simple as, hey, we're seeing malicious activity. You can simply enable a policy that blocks newly registered domains, and that'll reduce your risk dramatically. Or it could be, hey, we have identified this internal app segment that is not properly segmented, and here's a recommended ZPA policy that can cut down that internal risk quite a bit. And the goal here is, we all understand how busy you are. We want to prioritize the actions that you can take that will dramatically cut down that risk with little or no effort, right? So it's a combination of how much effort something is and what's the risk reduction benefit you get. Switching gears, I don't know of security companies who are as passionate about user experience as Zscaler is. In fact, I'd say at Zscaler, we strive to deliver outstanding security with outstanding user experience, not at the cost of user experience. A lot of you know that we launched Zscaler Digital Experience a few years back. And I thought I'll share some growth metrics over the past year. In fact, if you look at ZDX, since Zenith Live 2021, we've had 5x increase in ZDX devices, 10x increase in the number of telemetry points that we are collecting, and 3 times the number of probes. You multiply all of that, that gives you a sense of the amount of visibility we have of user experience from across the world, across many, many users and countries. Now, for those of you who are wondering what ZDX is, just a quick recap. We, as a service, sit on the endpoint, we sit in between, and we see the front door of pretty much every application that your users are accessing. And we have a very unique vantage point. Traditional user experience in today's world is very fragmented. If, for example, you have a problem with your Zoom session yesterday and you call your IT help desk, you might have them look at your device. Maybe a separate team might look at the network. Maybe a separate team is looking at applications. And these siloed views make it very hard to troubleshoot when there is a real problem that is happening. You'd be lucky if after 2 weeks your IT ticket is resolved and your problem has been sorted out. So this creates a lot of alert storms in the organization, fragmented insights, and poor user experience. If you look at our approach, we are unifying all of these monitoring silos by giving you end-to-end visibility of why a particular user or a group or a location is having problems with a group or a particular application. We pick up telemetry from the endpoint, things like Wi-Fi, CPU, the type of software you've installed. We're looking at the hop-by-hop network between the user and Zscaler, between Zscaler and the application that you're trying to access. And then we're looking at a lot of application performance by looking at things like DNS resolution, page load times, et cetera. And we're able to combine all of that on a minute-by-minute basis for every user, for all the apps that you care about, and can pinpoint when issues are happening. So we talked a lot about features and enhancements and innovation. One of the most important priorities at Zscaler is reliability, availability, and scalability of the platform. We understand how mission-critical the Zscaler service is for all our users. We understand that even a small glitch can have a lot of business impact. And as Andy Jassy famously remarked, there is no compression algorithm for experience. We've been doing this for 15 years. I thought I'd share two important updates. One, give you a sense below the hood of what's happening when it comes to running this platform. And second, a lot of customers have asked us, if there is a black swan event with Zscaler, what BCP DR options do I have? So let me start off with a quick glimpse of under the hood, what's happening when it comes to running the platform. We have continuous software updates that are being pushed on a weekly basis. This is to optimize performance, enable new features across all the things that we talked about today. And we've done a lot of AI ops monitoring and automation in our deployments to make these upgrades zero impact. You can have a SaaS application that can post a maintenance notice. For Zscaler, we got to service these engines while the plane is flying. We're constantly pushing new threat intel into the platform, 250,000 new threat indicators every day. Any one of them could have an issue and could potentially be a false positive block. So we've done a lot of automation when it comes to real-time testing of all of these changes getting into the platform. So you get the latest and greatest threat protection without any disruption. Our operations team is constantly adding new data centers, lighting up services with new IPs, because that growth requires that capacity expansion. And finally, we have a huge compliance and security team that's constantly making sure that we are compliant with FedRAMP and SOC 3. We have red team pen tests that are making sure that our own platform is hardened. And while we are reducing your attack surface, our own attack surface is as tight as possible. So all of this is happening continuously. And it's our commitment to you to make the service as rock solid as possible. Now, having said that, there could be black swan events. And we would like our customers to have what I call, in case of emergency, break glass and have the ability to continue business for a short time if there was a significant disruption. So we are working on, and you will shortly see a feature which we call Zscaler BCP DR, Business Continuity. It essentially allows you to activate an option that will let you continue to access your internet and your core applications, even if the core Zscaler service was having a significant disruption. And how does it work? We thought about many different scenarios. We thought about how can we give you a UI button that your operations team can hit, but then what happens if that UI is not available? And the most consistent way we could come off with was DNS. So this BCP mode gets triggered with DNS. Your DNS administrator can add a simple text record to your DNS setting, and our client connectors are smart. They will listen to this DNS record, and if they see it, and you can cryptographically sign it, and all the security protections are there. But once they see this DNS advertised, they will assume that the cloud service is not available and start getting into this BCP mode. For Zscaler Internet Access, that's pretty straightforward. You get three choices. You can fail open to the internet. Your users can go to the internet to all destinations. You can fail close if you're a very sensitive organization. But we are also introducing a third option where you can have your custom blacklist and whitelist. These are locally persisted on your client with a backup available in Amazon S3, completely decoupled from the Zscaler service. And this allows your users to go to whitelisted destinations and not to the blacklisted ones. So the ZIA piece is pretty straightforward. The more tricky one is Zscaler Private Access. Because of the zero trust design, there is no network path if there is a significant disruption there. But the way that works is also pretty elegant, and I wanted to kind of give you a quick glimpse. In regular mode, all your users and your workloads come to Zscaler. Your applications in your data center and public cloud environments are exposed through our app connectors with an inside-out tunnel. And the ZPA brokering service, based on policy, is connecting users to destinations that they should go to. That's how it works in the regular mode. Once you activate BCP with the DNS record that I talked about, we fail over to a private service edge. The private service edge is essentially ZPA brokers running in your environment. And with the BCP design, it will be fully site survivable. What that means is it will boot up without relying on any cloud configuration. Any users that have authenticated to the ZPA service, ZPA uses client certificates, and on top of that, user-level authentication. So any user that has authenticated even once will be allowed access to your internal applications through that private service broker, which does not rely on any cloud service being available. So we hope that you don't have to use it ever, but given how mission critical the service is, it's good. It's a good exercise to plan. And I look at this as, in case of emergency, break glass, that's an option that's available. We'll be happy to answer more questions around this. But that brings us to the end of our innovations keynote. Innovations is in our DNA. We are over 300 patents now. Our code base has grown to 15 million lines of code, and we are continuously driving more and more exciting inventions on the platform.